Hi everyone, welcome to our video lesson on 8.3, Test for Parallelograms. 8.2 we talked about properties of parallelograms, and there were 6 properties that we talked about in detail. Today, for Test for Parallelograms, it's kind of like the converse of those 6 properties. So yesterday, we said if a quadrilateral is a parallelogram, then this OSC right here stands for opposite sides are congruent. If a quadrilateral is a parallelogram, then the opposite sides are congruent. So now let's switch these if and then statements for the converse. If the opposite sides of a quadrilateral are congruent, then it is a parallelogram. So if this side is congruent to this side, and this one is congruent to this one, is this a parallelogram? The answer is yes, or true. The converse is also true. Another property is that the opposite angles are congruent. So yesterday we said that if a quadrilateral is a parallelogram, then the opposite angles are congruent, that if-then statement. Now on the converse, we're going to switch around the if and then statements. So if the opposite angles are congruent, then it is a parallelogram. If the opposite angles of a quadrilateral are congruent, then it is a parallelogram. This is also true. If this angle is 100 degrees and this angle is 100 degrees, this angle is 80 degrees, this angle is 80 degrees, then we have a parallelogram. This one stands for consecutive angles are supplementary. If a quadrilateral is a parallelogram, then the consecutive angles are supplementary, so the angles that are right next to each other add up to equal 180. How about the converse then? If the consecutive angles in a quadrilateral are supplementary, then it is a parallelogram. Another true statement. If the consecutive angles add up to equal 180, this is a parallelogram. This DB, that means that the diagonals bisect each other. So yesterday we said that if it is a parallelogram, then the diagonals bisect each other. Today we're going to say the converse of that. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Also a true statement. Why aren't you going back here? Rats. And then we have the D2T, means that the diagonal makes 2 congruent triangles. If a quadrilateral is a parallelogram, then each diagonal cuts the parallelogram into 2 congruent triangles. So the converse, if the diagonal cuts a quadrilateral into 2 congruent triangles, then it is a parallelogram. Also true. And then the last one that we didn't really talk about yesterday, but we're going to talk about it today. If one pair of opposite sides of a quadrilateral are both parallel and congruent, then it is a parallelogram. This one's also a true statement. And the reason for that, if this side is parallel to this one, and we would call this the transversal. And the transversal would create consecutive interior angles, which are supplementary. So if these two add up to equal 180, it's kind of like the consecutive angles are supplementary in a parallelogram. So this one is also true of parallelograms. So now we're on to proving if a figure is a parallelogram or not. We want to graph them and get a picture of what they look like, but that isn't enough. You cannot simply tell whether a quadrilateral is a parallelogram simply by graphing it. It might look like one, but it might not be. Or it might not look like one, but it is. So we have to, it's a must, we must prove if it's a parallelogram by doing one of 2 things. You either have to prove that the opposite sides are congruent using the distance formula, or you have to prove that the opposite sides are parallel using the slope formula. So let's refresh ourselves on the formulas of these. The distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. The slope formula is the difference of the y's in the numerator, y2 minus y1, over the difference of the x's in the denominator, x2 minus x1. So class, we're going to be doing this many times. What's better than doing the distance formula once? There are 4 sides in a quadrilateral, so we have to do the distance formula 4 times. Or we have to do the slope formula not just once. How many sides are there in a quadrilateral? There are 4. So we have to do the slope formula 4 times. One or the other. So let's do this. Let's first graph this. Point A is at left 3, up and down 0. So there's point A. Point B is left 1 up 3. C is at right 3 up 2. And D is at right 1 down 1. Question for you all, is this a parallelogram? Right now, you cannot say yes or no. You cannot tell simply by graphing it. You have to prove one of two things. Opposite sides are congruent using the distance formula, or opposite sides are parallel using the slope formula. We will do both in this video, okay? So we're going to do the distance formula 4 times. Let's first find the distance from A to B. So we're finding the distance between these 2 points. Here we go. The distance equals the square root of x2 minus x1. Negative 1 subtract a negative 3. That quantity squared plus y2 minus y1. 3 minus 0. That quantity squared. So negative 1 plus 3 is 2. 2 squared is 4. 3 minus 0 is 3. 3 squared is 9. So the distance from A to B is the square root of 13 units. This is the square root of 13 units. Let's now find the distance from C to D, shall we? If that is the square root of 13 units, then at least we have one set of congruent sides. Let's see. The distance from C to D equals the square root. Here I'm doing the distance formula between these two. C to D. We have x2 minus x1, 1 minus 3, that quantity squared, plus y2 minus y1, a negative 1 minus 2, that quantity squared. Negative 1 minus 3 is negative 2, and negative 2 squared is a positive 4. Negative 1 minus 2 is a negative 3, and a negative 3 squared is a positive 9. Would you look at that, everybody? We have the square root of 13 units as the distance from C to D. Square root of 13. So we're on our way. We're not done yet because we still have to prove BC is congruent to AD. Let's do that, shall we? You guys can keep this down in your notes. I'm going to erase it so that you guys can see it a little bit better. I want the distance now from B to C. The distance from B to C is the square root. I'm doing these 2 points right here. 3 minus a minus 1, that quantity squared, plus 2 minus 3, that quantity squared. 3 minus a minus 1 is 3 plus 1, which is 4, squared is 16. 2 minus 3 is a negative 1, square negative 1, and you get a positive 1. So the distance from B to C is the square root of 17 units. This is the square root of 17. All right, everybody, the moment we've all been waiting for. Let's find the distance between A and D. And let's see if it's the square root of 17 units. The distance from A to D is the square root of x2 minus x1. 1 subtract a negative 3. That quantity squared plus y2 minus y1. A negative 1 minus 0. That quantity squared. 1 minus minus 3 is 1 plus 3, which is 4. 4 squared is 16. A negative 1 minus 0 is negative 1. Square is a positive 1. And we get the square root of 16 plus 1, which is the square root of 17 units. Wasn't that fun, everybody? The opposite sides are congruent from A to B to C to D. They're both the square root of 13. The opposite sides are congruent from B to C and A to D. They're both the square root of 17. Now we can say with pure confidence, yes, this is a parallelogram. Whew. Now, some of you might not want to do the distance formula 4 times. And that's okay, because there is another way to prove if it is a parallelogram. The opposite slopes have to be the same. Or the opposite sides have to be parallel, which means that they have the same slope. So let's do this problem one more time all over again. This time, we're going to prove that it is parallel because the opposite slopes are the same. So left 3, 0, there's A. B is left 1 up 3. C is right 3 up 2. And D is right 1 down 1. Let's find the slope from, that doesn't look right, does it? Left 3, left 1, up 1, 2, 3. There we are. Okay. So we're going to find the slope from A to B right here. The slope from A to B equals, that's the distance formula, equals y2 minus y1. So from A to B, these 2 points right here, 3 minus 0 over a negative 1 subtract a negative 3. y2 minus y1 over x2 minus x1. 3 minus 0 is 3. A negative 1 plus 3 is 2. So my slope is a rise of 3 and a run of 2. 3/2. Let's do the same thing from C to D. And let's see if that slope is the same, because parallel slopes are the same slope. So my slope from C to D equals y2 minus y1, a negative 1 subtract 2, divided by x2 minus x1, 1 minus 3. A negative 1 minus 2 is a negative 3. 1 minus 3 is a negative 2. A negative 3 divided by a negative 2 is a positive 3/2. And there you have it, the opposite sides. We have one set of opposite sides that are parallel because they have the same slope, 3/2 and 3/2. Let's do the slope formula 2 more times to find the slope from B to C and from A to D. So my slope, my M, from B to C, between these 2 points right here, is y2 minus y1 over x2 minus x1. This minus this in the numerator, this minus this in the denominator. What do we get? A negative 1 over a positive 4. A negative 1/4 from B to C. Down 1, right 4. Let's do the same thing from A to D, and let's see if it's a negative 1/4. So my slope from A to D is the square root of y, rats, I did the distance formula again. Here we go. The slope formula is y2 minus y1, a negative 1 minus 0, over x2 minus x1, 1 minus minus 3. And we get a negative 1/4. So you again prove that it's a parallelogram because the opposite sides are parallel, because what do you know about parallel slopes? They are the same. So 2 ways to prove that a quadrilateral is a parallelogram: find the distance of all 4 sides, or find the slope of all 4 sides and compare them. Let me know if you have any questions when you get to class tomorrow.